Hey everyone, my name is Danielle Jobe. I work for VI Technologies. It's a software consulting company. We do a lot of LabVIEW based in the Netherlands. I'm a software architect, but today I'm going to talk to you guys about UI and UX design. This is a topic that I feel very passionately about, and I feel like I could probably talk to you all for days about it. So I'm going to try to keep it to 40 minutes. And I think we're just kind of going to scratch the surface. So it's just going to talk about fundamentals and how we can apply those fundamentals to scientific and engineering applications. Giants are female. I wanted to talk about Gladys West, who's a mathematician and programmer who grew up in rural Jim Crow, Virginia in the 1930s and 40s. Her parents were sharecroppers, and despite all those odds stacked against her and all that structural bias against her, she was able to study mathematics and wrote some really important programs that calculated the really precise models of the shape of the Earth using algorithms that accounted for variations in the gravitational, tidal, and other forces that distort the shape of the Earth. And that work that she did ended up becoming the basis for our GPS system. So I think that's really cool to, be aware of this role that this woman played in this technology, especially as a Black woman, since, so much structural bias against that. So disclaimer, before we get into the real meat of the talk. I'm a software architect, not a designer, although I do have a lot of opinions about design, as my coworkers know. You don't have to agree with me about all those opinions. And this talk is going to cover a lot of theory. It's kind of a crash course. You're not going to be ready necessarily to do a full UI UX design at the end of it, so you should probably hire a professional designer, but I'm hoping that after this talk, you'll all maybe have an appreciation of how much goes into UI and UX design and how, and maybe have some language to think about things and some places to start with. So I'm going to start off talking about user experience. We've all probably come across these doors where you walk up to the door and your first inclination on a door like this is probably to push it because it has that big bar going across like that. There's actually a word for a door like that. It's called a Norman door. It's a door where the design tells you to do the exact opposite of what you're supposed to do, and you probably need a sign to correct it. This is something that we're all so familiar with in our day-to-day lives. And the reason why it's called a Norman door is because it was first really talked about by this guy named Don Norman, who wrote this book called The Design of Everyday Things. And he's talking about how all these things that we're interacting with in our day-to-day lives have a form that implies its function. And some things are more obvious what that function is based off of its form, and that makes it more usable, and other things are less so. And this book kind of sparked the revolution of the whole field of user experience design and talking about user experiences. So when we talk about user experiences, we're talking about how usable is a particular object. So what defines that? What makes something usable? It needs to be learnable. So you need to be able to accomplish your desired tasks the first time you're interacting with that design. It needs to be efficient. So once you've learned that design, you need to be able to quickly perform your tasks with minimal frustration, hopefully. And you need to be able to remember how it is that you performed those tasks, even if you walk away from that design for an extended period of time. That proficiency should be reestablished pretty quickly. And as you're working with the design, it's more usable if you're not committing a lot of errors, of course. And that those errors are not so severe and that you can easily recover from them. And finally, it should probably be satisfying and pleasant to use. So what is user experience then? It's basically all the aspects of that end user's experience when interacting with an object, and that could be software, it could be a whole company or a service or a door. There's actually a whole field now about just designing services, so it's kind of like an offshoot of user experience. But I want to think about the language we're using here a little bit, and instead of saying the end user, because that feels a little bit impersonal and I don't know, less human, I want to just say all aspects of a person's experience interacting with an object. And when I shift to phrase it that way, I'm thinking more about the psychology of the individual and the emotions that they're feeling behind their experience. And that leads us to human-centered design, which has a kind of design thinking process that begins with empathizing with the people using the product. And from that empathy and understanding who those users are and what they care about and what they're thinking about, we can define what problems they're trying to solve. And once we've defined what problems they're trying to solve, we can come up with ideas on how to solve those problems. And from there, we can create a prototype. And that prototype maybe gives us more ideas on how to solve the problem. And then we can test that prototype with the people who are going to be using it, or people who represent the people who will be using it, which will then give us more ideas, help us understand more the people using the product, and help us redefine how we understand the problems that they're trying to solve. And this human-centered design process, I think, is really important as we're thinking about the user experiences of our software. So when we're doing that human-centered design, there's a lot of tools that have been developed to think about the workflow and to think about the people who are using our products. And the first kind of thing we want to think about, like I said before, is empathizing with the specific users that are involved and that are going to be using our product. So a really popular tool is making an empathy map. I had a slide about that, but in the interest of time, I'm not going to go over it because it's quite involved and I find it might be a little bit less useful than some of the other tools. But I do want to mention user stories. I think this is a really common one that a lot of you guys might be familiar with. And it's phrasing a set of stories as a type of user, I want to accomplish a specific goal so that I can have some benefit. It's commonly used in agile projects. So for example, for our types of applications, you would have something like, as an operator, I want to load an experiment so that I can run it. Or as an operator, I want to view the status of an ongoing experiment so that I can know what it's doing. Or as an operator, I want to view the time remaining in an experiment so that I can know how long I have to drink coffee before it finishes. Or maybe as a researcher, I want to load the data from a previous experiment so that I can analyze it. And from those user stories, we can come up with a set of requirements, maybe feature requirements that we can implement when coming up with our prototypes for how our user interface is going to work. And with those prototypes, it's really useful to do some wireframing. A wireframe is kind of like a page schematic. So you're figuring out which elements are going where on the screen and how to navigate between the different screens. So it's kind of layout oriented and oriented towards which functions are available to different users and at what time based on what rules. They're awesome for rapid prototyping because they're often interactable, so you can create something that really looks like, to some degree, maybe without the visual design because it might be kind of rough, but you can create something that will function similarly to how your actual application is going to function, give it to your customer, and then, or your end user, whoever that may be, and have them play through it and that can be super useful for testing. I use a tool called Figma, which is my personal favorite one for wireframing. It's let's see if we go to the website. I don't know if you guys will see my screen or if I'm only sharing the presentation. Can you guys see the whole screen or just the presentation?
Just the presentation.
Okay, let me see if I can change that. Okay, now it should be showing the whole screen. Can you guys see the website now?
Yes.
Okay, cool. Thanks for feedback. So this is the website. It's great for rapid prototyping. I actually learned about it because I'm part of an organization called G Central, which Sam was talking about, kind of the crux of the problem that led G Central to exist, which is that we have all these different package managers for LabVIEW, and there's no one central location to find packages for G code, for LabVIEW code. So the idea of G Central is to have one place that you can go to and you can search for packages, be it in G Package Manager, NI Package Manager, or VI Package Manager. And we've been really busy the past year working on getting started and working on getting some designs going so that I'm actually starting the development, which has been well underway now. And I wanted to show you guys a kind of sneak preview of our wireframes that we have, which are done in Figma, which the designer that we're working with is the reason why I know about Figma. Super cool. So it doesn't have the visual design implemented. The wireframes are just kind of to show what's going to go where and how to navigate between pages. So if you're going to click on search packages, it's going to go to a page that's going to look something like this. And then you can scroll, click on a package, you can install the package, see some ratings and comments, GitHub link. So yeah, hopefully that's interesting to you guys, but this is kind of an idea of what a wireframe is and how it works. And so because he was able to, our designer, make this wireframe for us, we could play with it and see, I like this aspect of it, I like that aspect, I don't. G Central, by the way, is totally for the community, by the community. So if you guys are seeing this right now for the first time and you're thinking, oh, it would be cool if we had this and that, I can put a link in the chat to a forum post where you can give us feedback. We would love all your feedback. So that wireframe is amazing for usability testing, which is a really important aspect and a step in designing the user experience. So we want to get representative users, representative people, to perform the tasks that they're going to need to do with the software. The goal being to understand what the problem is and how to solve that. So as you watch them doing it, as you watch them using your prototype, don't tell them how things are going to go. Don't say, click here, click there. You have to watch them, shut up, and let them do the talking. Let them explain what they're feeling, what they're seeing, what they're confused about, and really pay attention to that interaction cost, which is, as you're moving through a piece of software, all of the clicks that you have to make, all of the areas that you have to look at in order to accomplish your goal. We want to try to keep that as minimum as possible to make things easier for our users. So I mentioned Don Norman, who was the kind of like father of the field of user experience. There's kind of two big names, I guess, in the field of user experience, and Jacob Nielsen is the other one. And together they have this research-based user experience group called the Nielsen-Norman Group. And Jacob Nielsen came up with these 10 usability heuristics, which I think are interesting to talk about as they apply to our types of applications that we do. The first one I think we're all probably pretty good at doing because it's so crucial is the visibility of the system status. We should be showing the status of the system and all that relevant information at a glance within a reasonable period of time. I don't think I need to spend too much time talking about that because we all know what that means. This one, though, I think gets a little bit more tricky as a programmer. We want to have a match between the system and the real world. So that means using words that are familiar to your end user, not system-oriented terms. And I think that I myself struggle with this sometimes. And we want to show information that is in an order that feels natural to the user. And I think this one can be kind of tricky to figure out. What is it that feels natural to the user? And it's a bit subjective and it's a bit by feel. So that's kind of hard. And I think a big part of how you come up with that, again, is that usability testing, rapid prototyping. User control and freedom. So it's going to be common that your users might get in an unwanted state. It's nice to give an emergency exit without having a lot of extended dialogue about it. So that's that undo and redo type functionality. This is super important to have consistent terminology and patterns throughout the platform. So of course, this applies to words. They don't want to be, don't want your users to be thinking, oh, does this mean the same thing as X mean the same thing as Y? Use the same words, but also the design patterns that you're using to solve the certain small issues, small problems in the software. Not necessarily in the code itself, but if you are usually having the user, for example, have the OK button on the right and the cancel on the left or something like that, keep those patterns consistent. If performing a certain type of action has you using, I don't know, a hamburger menu, or has you using a graph or a certain type of form, if you have multiple of that similar type of action throughout the software, keep it with the same pattern. And that consistency, I think, helps a lot. A good design that prevents errors is better than a good error message. So I always like to have little interlocks in my user interfaces that disable buttons or hide buttons so that the user can't just go all over the place. I love when I'm testing it to just like click everywhere on the screen. And if I can create an error, then now I know that that has to that has to be disabled in some way, depending on the state. But sometimes errors do happen. And if it does, we want to explain what happened in plain language, precisely indicate the problem, constructively suggest a solution. So this means not just saying error 7, file not found, but actually say something in the language that the user can understand and explain what they have to do about it. This can be a little bit difficult because we don't always know what all the errors we're going to run into are, especially when we're coming up with like a visa error or some kind of hardware error along those lines. There can be so many different codes, but it's good to, as much as possible, try to anticipate the errors that you can, that could be run into, and try as much as you can to, in your error handling, do something like this. Recognition rather than recall. So that means not relying on the user having to remember a lot of information between different screens in the software. So making everything visible that needs to be visible, and any instructions that they need in order to use the software also visible. So they're not just having to memorize a bunch of stuff. So this one, we want, of course, the software to be quite flexible and easy to use. But a big thing that they talk about with this is this concept of accelerators. And I would be inclined to say that this is less relevant a little bit to the kinds of applications we use. So an accelerator would be something along the lines of like quick drop for within the LabVIEW IDE. It's these keyboard shortcuts and stuff like that that speed up interactions for expert users. I always kind of feel like this is, you know, a nice to have in our applications, but maybe not super important. Similarly, allowing users to tailor frequent actions. It's like, if there's time, that's a really nice thing to add, but I would argue not the most important. But this, I would argue, is one of the most important. Keeping a minimalist design, because every single unit of information is competing with your relevant information. So this is so difficult because I feel like engineers are often thinking that they want to see everything. I remember having a coworker back years ago who was a PhD scientist, brilliant guy, and he would always say more data is good. And I understand and I sympathize with that sentiment, but at the same time, when it comes to a piece of software and a user interface, it gets really confusing really quickly. And especially if you're doing something that is kind of complicated, it's much easier to have just the bare bones, minimal, what you need. And finally, the last usability heuristic is having help and documentation that's easy to search, focused on the user's tasks, listing concrete steps to be carried out, and that's not too large, that's too cumbersome. This is another thing that I think a lot of customers don't necessarily want to pay for. And I'm not necessarily even just talking about documentation in terms of how the code works under the hood, but how to use it. But sometimes you can get some budget for it. Okay, I'm gonna shift gears a little bit and talk about the visual design. So all of that stuff was kind of more on the user experience side, which is maybe a little broader. And I think there's definitely a lot of overlap in terms of the visual design with the overall user experience. So the first aspect of visual design that I would like to mention is layout. This is the layout of elements that we have on the screen. And there's a few different components of layout that I'm going to go into a little more detail about. So that's the balance of elements on the screen, the scale of elements with respect to one another on the screen, and the grouping, also known as the Gestalt, of the elements on the screen. So I think this is something that's quite intuitive to a lot of people. We want to have a satisfying arrangement or proportion of elements. When we have balanced designs, they feel calm and stable. They feel natural. Imbalanced designs might make us feel uneasy. And balance can happen with equally distributed elements, although not necessarily symmetrical elements. Through an imaginary axis that's going through the middle of the screen. It could often be vertical, but it could also be horizontal. There's also such thing as asymmetrical balance. Asymmetry is will give you a feel of something with energy and movement to your design, and it's more dynamic. And symmetrical balance would feel more quiet and static and orderly. I would say for the types of applications we do and the types of users that we mostly will have, I would recommend going for a symmetrical balance more often than an asymmetrical one. It's not that like artsy trying to have this like use and movement thing so much probably. And now scale. So this is the relative size of elements with respect to one another. So we can see in this image, it's just a parking garage. We're at level H, and that's the most important thing for the users of this parking garage to know at this moment. So the people who've parked their car there need to know I'm at level H. That's more important than where are the stairs or the lift, although the other two things are important. So that relative size of elements with respect to one another is creating a visual hierarchy to add emphasis on certain elements. So there's a whole field of psychology just dedicated to this like Gestalt psychology. It's about how we combine all these separate smaller shapes into a whole shape, which is, I think our minds naturally do this because we want to see patterns. We want to see patterns based on different rules. It's kind of similar to how, you might see a face everywhere, like you look into a tree and you see these two dots next to each other, and if something even slightly resembles a face, your mind is going to turn those separate shapes into a whole, and a lot of times it'll be a face. So There's a few different types of groupings that our minds might do, and I'm just going to mention a couple of them here. Similarity, so we're going to group together in our minds those peach-colored dots with the peach-colored dots and the pink ones with the pink ones. Common region is when you have maybe some kind of background behind it to group together items. And proximity, of course. And I feel like a lot of this stuff is like quite intuitive and we all kind of know it, but this is just kind of some terminology that we can use in a way to think about it more concretely. So using this grouping, it's helpful to be able to help the people using our software to understand what they need to see immediately. And it can make things a lot clearer, or it can make things a lot more confusing, having good or bad grouping. So color is fun. I would recommend in your software applications to always make a color palette when you're starting off with the UI. With the color palette, I often actually make a VI that has an array of color boxes that I set to the specific colors that I'm using in my color palette, because then I find it makes it really easy to get the dropper and get those colors when I need to. And I'll add like a comment of text below it on the front panel saying like, this is the primary color and these are the RGB values, this the secondary color, this is the background color, this is the text color, and so on. I find that super helpful, so that's my little trick for you. Again, I would recommend to have a minimalist color variation, so not being super all over the place with all the different colors. Every color kind of means something, so it's good to think about that. And brand colors are always nice to use. And when we're using that color, we want to think about how it's influencing the hierarchy of the information that we're seeing, that visual hierarchy. And every single color has a particular meaning, so we want to be consistent about that between the application, or between the different parts of the application. So like error being red, that's pretty common. Let's see. Color indicating state and interaction, yeah, so oftentimes we'll use colors to say what state we're in the application. And of course, you're going to change colors on your Booleans as you press it, so that you can indicate that you pressed a Boolean and stuff like that. We want to use enough contrast so that things are visible, because above all, with all these designs, it must be legible. Along similar lines, typography. I recommend establishing a consistent type scale and using it throughout your application. So having different types depending on the level of text, type of information that you're showing, have a definition for how large you want that text to be and the font weight. And please use one font. This is like a pet peeve of mine, when people are having their application like 6 different fonts. And dear God, please don't use Comic Sans a mess. But this is one of my opinions. You can disagree if you want. Because above all, it just has to be legible. That's the main thing. Okay. Icons, this is a fun one. And another thing that I have really strong opinions about and get really sometimes my eyes hurt when I look at applications with their icons. And it's tricky, I think, because there's a lot of kind of really subtle aspects to the size of the icons, the positions of the icons. But I would say one of the most important things to think about when choosing icons is to keep it simple. Like I was talking about before with that minimalist aesthetic, every unit of information is competing for attention. So the most minimal you can make an icon while it still is representing that concept and is recognizable, I would say the better. So looking for minimal geometric but recognizable icons that are symmetric, that have clarity at a small size, with consistent stroke weight. So the stroke is, I don't know if you guys can see my mouse, but the width here of each of these lines, you'll notice they're all exactly the same width. That enables some consistency throughout the application, and that just preserves some of that like UI magic that makes people think the software is magical instead of being aware that like, oh, a person made this. This is the thing I think that is the trickiest, the icon size. I feel like I'm constantly seeing icons that are not really adequately sized for the buttons that they're in. There's kind of like an optimal size, and it's really hard for me to put into words what that size is. But there should be adequate space around the icons because that negative space is also really important in just making it look balanced. If you're in doubt about icons, I highly recommend downloading the icons from material.io, that's the Google material design, or using the JKI flat UI controls. There's the flat UI controls 1.0 and flat UI controls 2.0. They're awesome, both of them. Highly, highly recommended. Okay, so I'm actually doing a lot better on time than I thought. I got rid of a couple of slides because I was like, there's no way that I can cover all of this. So applying all of this to a LabVIEW front panel. So I did a presentation a few years ago when I was at JKI about how to customize controls, how to take a design from a designer and apply it to an actual VI, like laying all the elements out and what to think about when you're using touch UIs. I highly recommend watching that presentation. It's still up on the JKI blog. Someone also JDP flatline controls on VIPM. I've never seen those before, but someone is recommending those. But yeah, there's, oh yeah, someone linked the talk in there, thank you, it's in the chat. But I highly recommend watching that. I'm not gonna do all those things again today because it's already up there for you to watch. But if you're not familiar with the fact that you can create custom controls in LabVIEW, it's pretty, yeah, to me it kind of like revolutionized the way that I make UIs, because other than that, you're kind of stuck with either those packages of other people's controls or, yeah, silver controls or, you know, modern or classic or whatever. I mean, system I feel like is generally an okay choice, but you can really take it to the next level with those custom controls, and you can really use like drop shadows and all kinds of stuff like that that can make your UI look a lot nicer. So some resources. The top link is for the Niels Norman group, which is the people that I was talking about at the beginning of the presentation who kind of like founded research-based user experience. They have tons of resources on this website. Articles, training. I find it really useful when you're trying to learn about user experience and kind of things to think about and different tools. Figma, I already showed you guys, is that wireframing tool and design tool. There's also, it's pretty widely used, so there's tons of resources out there that like templates and stuff like that that people have made for Figma. I think that kind of the trickiest thing that we face as developers working on scientific and engineering applications is that pretty much all of the resources about UI UX are geared towards web and mobile applications, which makes sense because I think most applications are web and mobile. But we kind of have a different set of problems that we're trying to solve. I mean, so we're not our goal isn't to have a website that people are buying stuff from. Our goal is to help a scientist or an engineer, perform their tests. And I think that creates a different set of problems, which creates a different set of design patterns that we're going to need to use in order to solve those problems. And so that's kind of like the tricky thing that we face, that a lot of those like common resources online are not really solving. And I would kind of be interested in compiling a set of design patterns to solve those specific problems that our users are facing. So if you want to chat about it with me at some point, feel free to reach out, and I want to compile a list of kind of like what are all the problems that our users face, like what are they trying to do all the time, and how have you solved that? Like, how do you enable your user to build a recipe or edit a recipe, or how do you enable your users to run their experiments or analyze their data or whatever it is? Like, what are the specific tools that you've used on your user interface in order to solve those problems? And I'd be really interested in compiling kind of like a quite extensive list on all the different options and doing some thinking about what's working the best, and maybe publishing that in some way, shape, or form, maybe a presentation or something. Because I do think a lot of those design patterns are really quite geared towards web and mobile, and that's unfortunate for us. But it doesn't mean that a lot of the same concepts don't apply. So along those lines, there's the Google Material Design Guidelines for Visual Design. It is totally geared towards web and mobile, but so many of these concepts are 100% applicable to us. So kind of design guidelines for how to lay out things on the screen. Responsive grids, that's a little bit different for us because we don't have Bootstrap or the grid layouts like they do on web. If someone could make a package for LabVIEW that was like Bootstrap for LabVIEW to do responsive grid layout, that would be so cool. I would be your friend forever. But this resource I think is super useful, and one of my favorite things on here, let's see, are the Google Material Design icons. This is my go-to whenever I need an icon for a UI. Super useful. You can just say, okay, I want a check mark, let's say. I think they're all really consistent. They look really nice. They're flat. You can decide, say if you want a black or white. It's free. It's free. It's free. That's pretty cool. And then you can download a PNG or the SVG. I like downloading the SVG also. Sometimes I don't want the icon to be black or white. Maybe I want it to be a slightly different color, maybe slightly off black. I'm a big fan of like, RGB 60, 60, 60, like just barely off black. I think it is a little less shocking to the eye than full black. So sometimes I'll download the SVG and then open it up in Illustrator or Inkscape and then change the color. And then you can also, when you download it as SVG, you can export it to the exact pixel size that you want, which is super nice. Oops, I did not want to go back. How do I go back? Okay. So for those custom icons, if you want to make them yourself or edit those SVGs, you can use Inkscape, which I used for a long time before my very nice boss gave me access to Illustrator, which is way better, but it does cost money. So you should ask your very nice boss. Maybe they will let you use it. Here's that link to that custom controls in LabVIEW talk that I mentioned, that someone put in the chat. And then the JKI flat UI controls. So there was the 1.0, which we released while I was still at JKI. Oh, that is linking only to the 2.0. Yeah, so this was just a set of controls. And then they went back and made an even better version, which is the JKI Flat UI Controls 2.0. Super nice. A lot of controls in here with a lot of different icons. And the cool thing about these ones is they're all customizable in terms of the colors. And I think this is a really nice starting point for making your own custom controls. At least this is what I use a lot of times. I'll start with one of these and then add my own icons and yeah, change the colors around as desired. Cool thing about these ones is Eric, the designer at JKI, he made these and he added a super nice drop shadow. You can't really see in these, but it looks super slick. Someone says, worth noting that JKI uses a proprietary license, which requires giving them credit. That is worth noting. I'm not sure in what way you have to say this is from the JKI flat UI controls, but yeah, it's good to note that you will have to mention that somewhere. Let's see, what did I want to mention? Oh yeah, also the graphs on here, I think are really nice graphs, but be aware that the default plot thickness is really thick, and sometimes that makes it a little more difficult to see the stuff, to the data. It's kind of like, you know, it looks nice design-wise, but maybe forgetting that rule that above all, it must be legible. So if it's clear enough, it's clear enough, but I often will go to a smaller plot thickness. Yeah. Hover states. So yeah, super useful resource. I highly recommend it. Okay, I think that's everything that I wanted to go over with you guys. Thank you so much for your time. I hope that this was at least somewhat interesting. I know it's not the usual content. It's kind of taking things in a little bit of a different direction, but hopefully you were able to get some kind of something interesting and some kind of information out of it. Does anybody have any questions?
I don't have a question, but just a comment. It was really useful with all those links you provided. I always find myself trying to design a user interface and I don't get anywhere basically. And then you have to go and try and recreate what you've seen somewhere else, and then I just don't get it right. So my question really is, I mean, you talked something about the psychology behind user interface design. Do you have any resources where you refer to these?
Yeah, that's a good point, and it's really, I think it is really tricky. Like this website, the Nielsen Norman Group, I would say that's kind of like the first place I'd go to for that psychology behind the user experience stuff. They've got a lot of articles in here. They also have a lot of training that you can look at with these training courses. And they have a course that's several courses that get into some of that psychology behind it. Because I mean, so much of the user experience is about that psychology, right? So yeah, they've got tons of stuff in here with that, and I do recommend that. I find it really useful. She says, I can also recommend the Wireframe podcast from Adobe. Okay, cool. I haven't seen that. Nice.
Okay, great. Thank you.
Yeah, you're welcome. It's a good question.
That's great. Thanks a lot, Daniel. Appreciate that.
Yeah, thanks, guys.